So actually our last chapter, that is actually lexical analysis, that is actually chapter number 3 of compiler design reference book, and where we learned many things and very details of lexical analysis. And now our topic is actually syntax analysis. And at the time of discussing the introduction chapter, I said that each phase of compiler actually a chapter. So now I am going to discuss about syntax analysis phase in more details, more elaborately. Okay, and we know that our lexical analyzer. So we know that our lexical analyzer produces a set of tokens from a stream of character. Then this set of token or stream of character will be the input of parser. Okay, and our parser will produce syntax t or parse t. So here I use syntax t or parse t, but actually syntax t and parse t actually not same. So actually parse t is more details than syntax t. They are almost same. They are very close, but they are not same. So your parser produce parse t or syntax t. So your syntax analyzer or parser takes stream of tokens that are produced by the lexical analyzer. Then your parser apply. Suppose we use Bangla language. So suppose I use now I am using English. Suppose I say that I eat rice. So I eat rice, it is okay. But someone said rice, I eat. So actually it is not okay. So, or more peculiar, like student, like go, not like that, like student, then suppose eat, then suppose then swim. So is it actually meaningful? So the word is okay. Student eat swim. The word okay, but it is meaningful.
No, sir.
It is actually not meaningful. It is meaningless. How we can consider it is meaningless? Actually based on the actually grammar of English language. Okay, so your syntax analyzer takes stream of tokens, then it apply the grammar. So many times I pronounce the word grammar, and in this chapter we will learn elaborately about grammar. So actually grammar is part of syntax analysis phase. So your syntax analyzer apply grammar on those token to check, to verify that it is okay or not. Okay, got it? If it is okay, then it will produce parse t. Got my point? So your syntax analyzer or parser takes stream of tokens, then it apply grammar to check, to verify that the token is okay or not. Okay, got it? Hello?
Yes, sir.
So this figure is more actually it's more elaborate figure. Okay, so and when we learned, when we were discussing chapter lexical analysis, that time I said that some rule of lexical analyzer, rule of lexical analyzer. Suppose some rule of lexical analyzer are, first one is suppose it identify keyword, then it identify, maybe this question, no, this question maybe for section I. So actually some rule of lexical analyzer, like it produce stream of token, it removes white space, is remove comments, then it identifies which one is keyword, which one is identifier, and it also actually able to identify lexical error. Is it? So those are the function, those are the rule of lexical analyzer. But now my question, what is the rule of syntax analyzer, or what are the function of the syntax analyzer? So at first it produce a parse t or syntax t. So it produce a parse t or syntax t, and if there is any syntax error, suppose you forget, suppose this is your statement, and you forget to put semicolon at the end of the line, suppose in C program, so it is syntax error. So this syntax error is also actually detected by syntax analyzer. Okay, got it? So it will produce parse tree or syntax tree, and if there is any error, if there is any syntax error in your source code, that time also the syntax analyzer detect it. Got it?
Yes,
Hello?
sir.
Yes, sir.
Yes, sir.
Then another responsibility or another function of syntax analyzer is recovery, error recovery. Then what is error recovery? So actually, are you familiar with the word recover? So suppose
Yes, sir.
we took vaccine of coronavirus. That is actually prevent. That means before infected, you just save yourself. That is actually prevent. But suppose someone actually infected by coronavirus, that time he will actually recover himself from coronavirus, and then he will be able to lead a normal life. So that is the recover. That means at first you are infected, then you are actually you are okay. So at first you detect it, then you need to recover. So in our programming, in our source code, there may have many error. So your syntax analyzer actually detect those error and recover by itself. That is actually error recovery. So this task is also done by the syntax analyzer. Okay, so at first it will produce a parse tree or syntax tree, then it will detect the syntax error of your source code, then it will responsible for commonly occurring error. That means it will responsible for error recovery. Okay, got it? Yeah, please. Yes, syntax error. Syntax error. Yes, yes. Okay, and there are different types of error available in compiler. Actually, each phase of the compiler is responsible for error detection. So suppose lexical error. So lexical error, actually the errors that detected in the lexical phase. Suppose, just a minute. Suppose misspelling of identifiers, misspelling of keywords, then misspelling of operator. Suppose if, so it's a keyword, but you mistakenly write fi. So it is okay. So in the last chapter, I discussed this one. Okay. So this is actually lexical error. So you write fi instead of fi, but it should be fi, but you write fi. So this one actually lexical error. Okay. Okay.
Okay, sir.
Hello. Okay, lexical. This one is actually lexical error. That means misspelling of identifier keywords or operators. Then syntactic error or syntax error. Suppose printf. So you write printf and you just keep the opening first bracket but no closing first bracket. Then it is actually syntax error, because there should have a closing first bracket also. Is it? So this is actually syntax error. So suppose you have a string like IUBAT. So suppose you have a string that is IUBAT, and you put, so it's a string. As it is a string, you need double quotation. Is it? You need to put double quotation.
Yes, sir.
So
Yes,
you
sir.
put double quotation at first, but you don't put double quotation at last. That is also a syntax error or syntactic error. Got it?
Yes,
Yes,
sir.
sir.
Okay. Then semantic error. So actually semantic error actually related with operator and operand. And I think you know what is operator and operand. I think you know.
Yes, sir.
Yes, sir. Yes,
So
sir.
yes. So actually, some operation are performed in our source code. Some operation. So actually, operator perform their operation on the operand. So operators perform their operation on the operands. So the type of the operands is very important. The type of the operands is very important. Suppose consider this one. So how many operands there? How many?
2.
2. There is 5.2 and 2. There are 2 operands.
Yes.
And how many operator?
1.
One.
1. That is the modulus. So this operator actually perform it operation on both operands. Okay. So if you write this code on code blocks or any IDE, that means like C. Suppose you are writing code using C language. So you write this one. So this one actually error, because in C, the operands related with modulus operator should be integer, but here the first operand is double or float. That's why it is actually a semantic error. Got my point? So this is very important actually. So the type mismatch between operator and operand, that is actually semantic error. So as here we are using modulus operator, that's why we need those type of operand, and that type should be integer, not double or float. So this is actually semantic error. Got my point?
Yes, sir.
Yes, sir.
Then logical error. So it is very common error. Logical error. Then the next one is logical error. Okay. And what is logical error? Just a minute. And the code is actually, the problem is, if the value of x equal to 4, that time it will show a as output. The problem is clear. Suppose I want to write a code where when the value of x equal to 4, that time it will show the output. That means a or a. Okay. So what is the output of the first one? What is the output of the first one? What is the output? Error. Why error? So no output because the condition is not fulfilled, is it?
Yes, sir.
So actually this is our actually code. Actually we want to write this code. Okay. So when the value of x is 4, that time the output is a. That time the output is a. Otherwise no. So this code is okay. But mistakenly you you put this only one equal. So we have this one actually equal and this one is assignment. So at the time of writing code, mistakenly you write only one. Then what will be the output of this code? No.
Error.
No.
Error maybe, sir.
No error. No. No. It's a logical error, but the output is a. It's a logical error. You mistake, but that mistake is right according to the syntax. Okay. You mistake, no problem. Suppose you write thousands lines of code, and your goal to add 2 number, but this code multiply 2 number. But this code is able to perform some tasks, no problem. But your goal is not fulfilled, is it? So this code actually will gives output, but your goal will not be fulfilled. And how it will show output? Just a minute. So actually we know that if is a condition, and in the first bracket, if is actually statement where in the first bracket there is a condition. If the condition is true, then the statement between this second bracket will be executed. Is it?
Yes, sir.
If the if the condition of if is true, then the statement between second bracket will be executed. But so this is actually condition, and the value can be 0 or 1. That means Boolean. If 0, that means the condition is false. If 1, that means condition is true. So you write x plus 4. So there is any wrong. So it is possible according to the syntax. You just assign the value of x to 4. 4 is assigned to x. So according to the syntax, it is okay. That means the value of this one, that is 1. As the condition is 1, that means the output is A. So you mistakenly write only 1 equal, but as syntax is okay, that's why it will show the output. But this is logical error. Okay, got it? Hello?
স্যার সেকেন্ড ইফটা যদি আবার একটু বুঝাই দিতেন স্যার, বুঝি নাই স্যার।
কেন আপনি আপনার প্রোগ্রামিং কোর্স করছেন না, আমার তো এটা এখানে বোঝানোর দরকার না, কারণ এটা তো প্রোগ্রামিং কোর্সের পার্ট। এটা মানে হাউ
বুঝতে পারছি, এখানে 4টা অ্যাসাইন হলো, অ্যাসাইন হয়ে মানে ভুলাই ফেলাইছে স্যার।
এটা তো আচ্ছা আপনার তার মানে কনসেপ্ট আপনার ক্লিয়ার না। এট দ্য টাইম অফ অ্যাকচুয়ালি জাস্ট a minute, some people raise their hand. Why?
Yes, sir. I have a question, sir.
Yes, please.
Sir, in the case of 5 divided by 0, what kind of error it will be?
5 divided by 0. That is actually
Yes,
division by 0 error.
Yes, sir. Is it syntax type any error?
No, it is not syntax type error. The syntax is okay. Hello?
Mathematical error.
Hello, sir.
Yes. Abu Bakr Abdi,
Yes, sir.
please.
We can.
Sir, if we write like x equal to 4 in terms of x equal to 4, some of
Yes.
the compilers like VS Code, it give us syntax error.
No. Is it? But actually it doesn't show any error. Try it. It doesn't show any error. Okay.
Yes, sir. It's showing syntax error.
Syntax error. No, it doesn't show any error. The code will be run, no problem. This one actually logical error. The syntax error, no. The code will be compiled successfully. Actually, this one actually part of your programming course. That's why I don't want to explain it. Okay, so why x equal to 4 is actually work here. Actually, this one actually you are part of programming course actually. So আমি ফিজিক্যাল ক্লাস আপনাদেরকে এটা একটু ভালো করে বুঝিয়ে দিবানি, কারণ এখন তো অনলাইন ক্লাস, এটা মানে জিনিসটা মানে ড্র করতে আমার একটু ঝামেলা হচ্ছে। ফিজিক্যাল ক্লাস আমাকে একটু মনে করাই দেন, এটা আমি ভালো করে বুঝিয়ে দিবানি। মানে এটা আসলে বুঝাইতে, if I want to actually give you clear idea, that means I need to actually explain how if is working. So how if is working, that is actually part of your programming course, not compiler course. Okay,
Sir,
Hello?
it also, sir, in the Eclipse, sir, it shows syntax error. Say x equal to 4.
where?
Say Eclipse also show syntax error.
If that means Java, in Java.
Yes, sir.
No,
Is it Java, not Java, sir. Okay, sir. Understand.
Yes,
Understand,
in
sir.
code blocks. Try to it in code blocks. Okay. So I will explain why it is possible. Yes, why it is possible. I will. Okay, please. Actually, that is actually issue of programming course, and in the physical class, please remember this one. I will explain. So actually the condition means actually 0 or 1. That means Boolean value. So anything correct, that is the value actually 1, and anything wrong, the value is 0. That's why if 0, that means no execution of the under no execution of the course under the if, like that. So actually I just skip this one. Okay. Hello. So why x equal to 4 is working, that I will discuss, no problem.
Okay, sir. Please continue.
Okay, sir.
Okay. Actually, that is not actually part of this course. Actually, that is part of your programming course. So this is actually you actually logical error. Okay, so error recovery. So if you want to recover anything, at first you need to actually detect. Suppose you want to handle something, that means at first you need to detect that one, then you need to recover. Is it? So if you think our GCC compiler, like suppose you are writing C code, suppose. So if there is any error, there is actually no successful compilation. That means failed compilation. Is it? If your source code contains error, that means that is actually failed compilation, no successful compilation. Is it? Hello?
Yes, sir.
Hello? I don't.
Yes, sir. We can hear
so
you.
that is, sir, that is actually failed compilation. So actually, but there are some compiler available where if some errors in your source code, those compiler solve the problem, those compiler actually resolve, those compiler actually recover those error by itself and continue its processing. But if you think C code, if you have error in your source code, that time actually it just actually just no actually successful compilation. That means no exe file will be created. But some compilers are available where those compilers are able to solve the problem of your source code by itself. Okay, then how it will be able to solve those problems. So suppose our body, so suppose a very weak virus actually enter your body. So that time you don't need to take medicine because your body is able to actually remove those virus because there is antibody in your body. But some very strong virus enters in your body, that time you need to go hospital, you need to take medicine. Is it? So those types of compiler, when faced like very silly mistake, very common and very small mistake, that time those compiler are able to solve the problems, and it solves those problem by itself, then it continue its task. Okay, got it? Hello?
Yes, sir.
Hello? Okay, so suppose you have a machine, and suppose 4 students. Hello? Please mute. Noise from maybe some from someone noise produces. Please mute. So actually suppose you have a machine and 4 students tell the machine actually about their commonly occurring problem, their commonly occurring mistake. So suppose you have a machine and 4 students actually tell their commonly occurring mistake. So when that system actually will observe those mistakes, that means he can easily understand this is a mistake. So he can actually tell you that this is a mistake. You can solve this mistake by like this one. Okay, but it is not possible to tell all the problems to the system. Is it? So those commonly occurring problem are actually can be solved by compiler. Those are very common. Those are frequently actually occurs. Those problems can be solved by the compiler by itself. Not all the problems. Okay. Hello, Tohid. Got it? Hello?
Yes, sir. Yes, sir.
Sure?
Yes, sir.
Okay. And for solving those like Turbo Pascal compiler actually has this error recovery ability. Okay, sorry, not Turbo Pascal, actually Turbo Pascal. Actually, to solve common occurring problem by the compiler itself, there is some strategy. Okay, there is some strategy. That means there are some approach. And by applying those approach in our compiler, we can solve those commonly occurring problems. Got it? And the first one is panic mode recovery. First one is panic mode recovery. And what is happening here? So suppose at first you write this one, and this one is data type. Is it?
Yes,
is
sir.
it? Yes. So we know that after data type in C program or other program, there should have an identifier.
Yes, sir.
Yes, sir.
So think. So if you write and write a data type, that then immediately after you need to write an identifier. Is it? Okay. So you suppose it starts to actually scanning. So I, then N, then T. So it is okay, no problem. Then A. So it is the data type, then A, and A is the identifier, so no problem. Okay. Then this comma. So when after this one, it will get 5. But according to the definition of the language, after data type, there should have an identifier. But we also know that there is a rules of identifier that it doesn't start with digit. Is it?
Yes, sir.
Yes. When your actually compiler finds 5 here, that time it will go to the panic mode. It will go to the panic mode, and then it will discard this 5. It will remove this 5 and one character at a time, and then it will remove A, then it will remove B, then it will remove C, then it will remove D, until it will get synchronizing token. And what is synchronizing token? Synchronizing token means int. So here comma I actually used here to indicate this one is int. Okay. So here comma is the synchronizing token. So when compiler finds error, that time it discards a character at a time until synchronizing token. Synchronizing token means comma, then while space, then colon. That means the int. Okay, it indicates the int. So I think this part is int by followed by this comma. So then that time the discard process is finished. Then it will get SUM. So SUM, no problem. So it is valid. It is valid SUM. Then a comma. So as identifier, it is okay.
So SUM okay, but space not.
So there is a comma actually. Sorry, there will be a comma after SUM. There will be a comma. Okay.
Okay, sir.
Okay. Then it will got a dollar. But we also know that a identifier can't start with dollar. So it will simply remove this dollar and these two until synchronizing token. And here colon is the synchronizing token. So your compiler, the error recovery ability compiler, remove this identifier and this identifier from the source code. Then it will continue its task. But normal C compiler actually has not this type of ability. That's why there is a failed compilation. But there are some actually compiler are available. Those have this ability to solve the problem, to solve the error by itself. Got it?
Automatically.
By compiler. Yes. Yes. Yes, because actually, so it starts with 5, that means the whole actually invalid. That's why it remove the whole, not like just 5, the whole. Someone please, you are pressing your keyboard. Don't need to actually show us that you are typing your keyboard. Please mute. Your speed is good, we know that, no problem, but please mute. Okay, someone maybe just typing and make noise. Your speed is good, that is good, no problem, but please don't disturb. Please mute. Who is he? Hello?
Sir, he messages his microphone problem. This is.
Okay. Okay. Oh, that is microphone problem, but like you are typing something like that. Okay, so got it. What is panic mode recovery? So when your compiler, not all compiler, when compiler discovering an error, it simply discard or remove input symbol one at a time until synchronizing token. And synchronizing token actually means the end of that one. Suppose here comma is used to actually indicate this one, the ending. Here like a colon is used to indicate ending. Then first bracket, the closing first bracket can be used to indicate ending. Okay. Hello. It is okay.
Yes, sir.
Yes, sir.
Yes.
Okay. Another one is phrase level recovery. Another strategy is phrase level recovery. Oh, just a minute. I forget to mention one thing. So panic mode recovery is very easy to implement. That's why it is most widely used. And when a statement has some actually a few number of errors, that time panic mode recovery is the best choice. Okay, so it is very simple to implement. That's why it is most widely used. And when a statement has a small number of errors, that time this one is the suitable. Acha, everyone please write down the examples, because those example is not present in the slide, which one I posted in the Google Classroom. So those examples actually is not present in the slide. So everyone write down, everyone please write down the example. Okay, everyone.
Okay, sir.
Write down the example, because that one I posted in the Google Classroom, where those examples not actually available. Because of the online class, I just put on the slide. Otherwise, I will actually write those examples on the whiteboard in the physical class. Yes. Yes, that means indicating ending. That is actually a synchronizing token. It can be white space. Suppose in Python, so no semicolon is needed. Like in so there white space is synchronizing token. Then it can be closing first bracket. That means ending. Ending means synchronizing token. Which one actually indicates the ending? That is the actually synchronizing token. Got it? Okay. Then phrase level recovery. So in phrase level recovery, some local correction is done. Some local correction is done. Suppose when your lexical analyzer finds problem in your source code, then it try to perform some local correction. Local correction means actually like a comma by a semicolon, replace a comma by a semicolon. Suppose look at this, integer a comma b comma, suppose mistakenly you write this one mistakenly, so your compiler replace this comma with semicolon. Got it?
Yes, sir.
Suppose
sir.
you write integer a comma b comma, so your compiler convert it to integer a comma b semicolon. Then suppose mistakenly you write integer a comma b, that means you mistakenly don't put the semicolon at the end of the statement. That time your lexical analyzer actually put that semicolon at the end of the statement. So this is actually some local correction. So this one actually known as phrase level recovery. So in phrase level recovery, when your compiler finds error, that time it will perform some local correction, and local correction means actually replace comma by a semicolon, then delete extra semicolon or insert a missing semicolon, those things actually, and then it continue its processing. Okay, and those things actually depends on the designer of the compiler. So actually it totally depends on the designer of the compiler, how the developer will handle. That is actually what is phrase level recovery. That means some local correction. Hello.
Okay, sir.
Okay, then error production. So error production, okay, just a minute. So suppose you have this input string, and you have this grammar. So we know that in our compiler actually there are grammars. Okay, if you break down your compiler, then you can see many grammars actually. So this is your input string, and this is your grammars. So everyone, please try to actually generate this input string with the help of this grammar. Then how? At first S to A. Okay, at first S to A. Then which production rule? The input string is A B C D.
Sir, A to AA.
A to AA, yes. A to AA. That means you get A already. Okay, you get A already. Then that means you need B, C, D. Then A to
BA.
sorry, A to
BA.
A to
BA.
BA. Okay, A to BA. Then
A to
A to A.
A to A. But the input string is ABA.
no, sir,
So-
no, sir. I am thinking.
But it is not possible actually. So it
Yes.
is not possible to generate this input with the help of this grammar. Okay, so sometimes your compiler have grammars, but that grammar is not actually enough to generate some input string. That time your compiler by itself change the grammar. Your compiler itself change the grammar. Suppose at first the grammar looks like this one, then your compiler change the grammar like this one, and this one is known as augmented grammar. That means your compiler augment already existing grammar so that the input can be accepted. So look at this one. This one actually new, and this one is known as augmented grammar. So when you add this one, that time actually augmented production actually. So it's a grammar I will discuss about grammar in the next class. So our next class actually based on just grammar. What is grammar? So when I will take the next class, that class actually on grammar. Okay, so that time you will understand the grammar more clearly. Okay, got it? So our next class on grammar, that time you will understand the grammar more clearly.
Okay, sir.
So each line of your grammar actually is a production rule. Each line. So each line of your grammar is known as production rule. So when you add a new production rule, suppose you add this new production rule. Okay, you add this new production rule. So that means you augmented the grammar. Augment মানে বৃদ্ধি করা. Augment like বর্ধিত করা. So you actually augment your existing grammar so that your grammar is able to accept this input. Got it? Got it?
Yes, sir.
So now try to draw with the help of this grammar. So at first, which production rule? At first, so this is the starting. So we need to take this one first because this is the starting. Okay. So it is compulsory to take the first one as first. So E2 SB. Is it?
Yes, sir.
Yeah, and S2 A. And A2 A. And A2 B. Okay, so we get AB and B will produce C D. Okay, so now your input is accepted by the augmented grammar. So sometimes the existing grammar of your compiler, just a minute, sometimes your existing grammar of your compiler is not able to generate a string. That time your compiler augment the grammar so that it is possible to accept that input. Okay, so by augmenting this grammar, we get this one, and this one is able to accept this one. So this is actually done in compiler, and this one is done by the compiler itself. But look at this. This one is very extremely difficult task. And here we use a grammar and the number of lines only 3. But if you think the real scenario, the grammar is very large. So if you change the grammar, you need to change the corresponding production rule. And this task is extremely difficult. Okay. So this is not actually widely used. Okay, got it? And what is error production? So you have already grammar, and by using this grammar, you are not able to produce an input. That time you need to augment. That time you need to change already existing grammar so that the input can be accepted. But this procedure is very difficult, extremely difficult, because you need to handle with grammars. And in actual life, the grammar is very large. Okay, got it? And this is known as error production. Hello?
Yes, sir.
Yes, sir.
So got it?
Yes, sir, got it.
And everybody, please write down the examples, because those examples is not available in the slide. Okay. At the physical class, like section H and I write those example on the whiteboard. Okay, that's why those are absent in the slide. So write down those. That is important. Yes, please. Abu Bakr, please.
Yes, sir. You know, the two examples here, the only difference is E goes to SB. Now, what's the difference?
Sorry?
What ESB means? What's E goes to SB?
So actually it's a production rule. So if you add this production rule in your grammar, in your already existing grammar, then it will be able to generate this input. But previously it is not possible. But if you modify your already existing grammar with this one, that is actually it is possible to generate. Suppose you have a water bottle that is capable to contain 2 liter, but you need to actually actually put 3 liter water. That time you need to actually increase the size of your bottle like that. That time your bottle will be able to accept 3 liter. So this actually grammar at first is not able to take this one. When we modify this one, that time it is able. And this modification is done by the compiler itself. But this is very extremely task. And I will take a class on grammar in the next class. Okay, no problem. That time it will be more clear. Okay?
Okay, sir.
Yes. Yes, augmented grammar. Okay, so any question? And I want to say again that I will take a class on grammar. I will take. Okay, that time you will know about production rule more clearly. You will be able to know. Okay.
Okay, sir.
Okay, done.
Yes, sir.
So Isha, any question? Is it clear?
Yes, sir.
But everyone, please just write down the example. That is important. Then another one is global correction. Another one is global correction. So if I will take 5 minutes more, any problem?
No problem, sir.
Okay. So suppose you have a grammar G. Suppose you have a grammar G and you have an input that is actually X, and this one actually incorrect. That means this one is not correct. That means incorrect string. This one is X and this one is incorrect string, and this one is the grammar. But this error recovery is not available in all compilers. Remember, this error recovery technique is not available in all compilers. So X is an incorrect string. So the compiler tried to make it correct. Is it? Now it is incorrect, but your compiler tries to make it correct. That is the error recovery from incorrect to correct.
Yes, sir.
Suppose when it is X, it is incorrect, but when it is converted to Y, that time it is correct. Suppose this is the correct. So when you make an incorrect to correct string, that means you must need to perform some operation, some insertion, some deletion, some modification. So it is not possible without performing any operation. An incorrect string will be converted into correct string. It is not possible. If you want to make an incorrect string to correct, that means you must need to perform some operation. Like suppose you want to make a chair from wood. So you need to perform some task to make from wood to chair. Is it?
Yes, sir.
Yes. In the same way, if you want to change this incorrect string to correct string Y, you must need to perform some operations on X. Operation means some insertion, some deletion, some modification, some update. Is it? So those things you need to perform on X, so that you will be able to produce a correct string Y. Okay?
গ্রামারের মধ্যে
না গ্রামারে না, স্ট্রিং এর উপরে।
ও আচ্ছা, ঠিক আছে।
নট গ্রামার, নট অন গ্রামার। ইউ নিড টু চেঞ্জ, মানে আপনার স্ট্রিংটাকে চেঞ্জ করতে হবে যাতে করে এটা কারেক্ট হয়ে যায়। বুঝছেন আমার কথা?
স্যার গ্রামার চেঞ্জ করলে স্ট্রিংটা কারেক্ট হবে না?
না গ্রামার তো ওটাকে বলা হচ্ছে error production. That is known as error production strategy. But now we are learn global production. The technique is different.
Okay, sir.
Now the technique is different. Okay. So actually, so we know that a problem can be solved in multiple ways. Is it? Suppose you can solve a math in different way. So you can suppose convert from X to Y in different way. Suppose this is the way, this is another way, this is another way. And if you follow this path, that means it requires 10 operation. This one require 8 operation. This one require 3 operation. This one require like 6 operation. So you can convert incorrect string X to correct string Y in different way. And the first way requires 10 operation. The second one requires 8 operation. Third one requires 3 operation. And fourth one requires 6 operation. Then which is the minimum? Which is the minimum?
3.
So
yes.
So in global production, just a minute. So in global production, your compiler choose the algorithm which need minimum number of operation for converting incorrect string X to correct string Y. Then which one will be selected? Which one? Which one? Which
Sir,
one? Oh, in global correction, your compiler choose an algorithm which requires minimum number of operations for converting incorrect string X to correct string Y. That means which has minimum number of operation, that will be the solution. Okay.
Yes, sir.
Then which one will be selected?
3.
Third one.
3.
Third one, yes. So this process, this algorithm will be used for converting incorrect X to correct string Y. Okay, incorrect string X to correct string Y. So minimum number of operation, that is important. In global production or global correction, minimum number of operation actually is needed. So this is known as global correction. But it is very costly. But this approach is very costly in terms of time and space. So we know that time complexity and space complexity. We know about time complexity and space complexity. So if you think the cost in terms of time and space, so this approach is very much costlier. That's why this one is theoretically exists but not implemented. So this one is actually theoretical concept, but it is not implemented. Okay, because it is actually huge costly. Got it? So those approaches, first one is panic mode recovery strategy, second one is stress level recovery strategy, third one is actually error production, and fourth one is actually global correction, and so on. Actually there are many way also available, but we cover only 4. So those actually used to recover error, and this process is done by the compiler itself. Okay, so if in the exam a question will come, explain different error recovery strategy, is it possible to answer? That time you need to mention the name, then some text, that means some theory, then example. So it is possible to answer.
Yes, sir.
Sir.
So got it? The question is explain different types of error recovery strategy. That time you need to write the name of those and some theory and like example for everyone. Okay, so actually what is error recovery? Error recovery means your source code may contains some errors and your compiler detect those errors, and after detecting those errors, your compiler solve those errors by itself. But those errors are actually very silly error, not a very complex error. Those errors actually very silly error and frequently occurring error, common error. But if the error is very complex, then your compiler is not able to solve by itself. That's time you need to solve by yourself, not by the compiler. Okay, so done. But if you look our C compiler, if an error, that means fail compilation. But those type of compiler, when finds silly error, that time it also be able to actually compile the code successfully, because those silly error, those common error, those general error can be solved by the compiler itself, so that it can proceed, so that it can perform its task. Okay, got it? So got it, what is error recovery strategy?
Yes, sir.